So, if some of you don't know me, I'm Oleg Gorbets from Global Product Marketing Team. And here with me is Evgenia Kirikova, who is the product manager for Kaspersky Embedded System Security. Today we are going to talk about naturally embedded system security, but before we proceed to the product itself, I decided that we need to check with the problematics. Well, what exactly we are doing it for. So first, all these specialized computing devices, this is what it is for, like ATMs, point of sale systems, payment terminals, medical equipment, and so on and so on. They are, similar in some aspects and dissimilar in other aspects. They all are, alike our usual computers, but then again, they have certain specifics, such as performing a very narrow scope of tasks or a single task for some of them, possessing very often limited system resources, having problems with updating and maintenance, having a newer supported IS may be a problem for such devices which have a really long lifespan compared to other computing devices. Many of them are operating in some common, unrestricted, and faraway space, and being operated by absolutely arbitrary people, passerbys, whatever. And the great deal of these devices also operate very sensitive people's data. So attackers, naturally, they know of all these specifics, bear them in mind. In some situations, they even benefit from these specifics. Such as, for example, in case of direct contact attack, when there is no physical perimeter and those people likely to be around, generally don't give it. If some bloke in overalls just casually approaches the ATM, opens the back door, and does some obscure technical operations to it, nobody cares. So another way to reach is naturally via the network. So it can be either using legitimate intrusion tools through all regular vectors, reaching to the office first and then moving laterally and then reaching the devices, then hijacking it with network exploit, infecting, and so on. Or it can be used in regular means, like using admin tools. Often it involves insider help, either within the company itself or in the supply chain. And let me note down that this particular situation is very uncommon with ATM and post services in particular. So being a pretty complex pieces of equipment, these devices, they change hands. Many hands actually during the multi-stage assembly process, and during the service stages they will change lots of premises several times. So the risk of having the infection upon arrival, especially if the device is not something brand new out of the box, is considerably higher than zero, unfortunately. And the latest trends demonstrate exactly that with many other types of devices. But to that we're going to get a little bit later. But now let us take a look at the threat landscape. The stuff really everybody likes, including the customers, because nothing sells better. Sorry for that, but a good scare always helps. So what is happening on the threat landscape in relation to the embedded devices? First of all, this graph shows the intensity of the specialized threat landscape, meaning the ATM POS malware in particular. Because, of course, there is a great deal of other malware that works okay with these devices that will just generic, they will target in any kind of computer. I personally believe that using the absolute detection number is not really useful, hard to interpret. But a number of threats per unique user or device, if you prefer, can characterize the intensity of the landscape. So what can we see? I'd rather say we observe a slight decline over the few years. So, but does it mean that criminals are becoming less interested in ATM and POS as targets? No, I'd say no, definitely. Just pay attention to the title. It's all about the specialized malware in particular. So the DTP is used against the devices also evolve as the devices themselves do. Therefore, there is a certain trend of the reduction of the specialized malware, but still we have pretty many of old specialized beasts still in use. Won't linger here for long, just worth to say that even these veterans are still, well, actively being used by cyber criminals. Those guys even upgrade their tool sets periodically. So only this year, I would rather say recently, my former colleagues from great team reported they found a new Prelix strain, for example. So no surprise here, because this guy is actually not just not a regular cyber criminals. They are already evolved into running a malware as a service enterprise. So they just cannot also allow themselves to sit on their buttocks, because the competition is always there to take over. So, but still, there are some new interesting cases that worth mentioning here. So, as I already have told you, so the current zoo of specialized ATM POS malware is kind of a sleepy one, because general purpose TTPs in many cases do what the crooks need them to do. But for jackpotting, the retrieval of the live cache, if you didn't know, some particular types of software is required. The one that would be able to operate the peripherals, such as the dispenser. So the angry competition now there. So the fresh jackpotter here, named Fixes. This thing sits on the top of CNXFS framework. This kind of intermediate layer designed to make it easier for middleware creators to operate, different peripherals, such as these cash dispensers in particular. So making such software therefore vendor agnostic, because, not needing to support lots of different types of dispensers, writing drivers. They just need to support a single API. And these guys are happy to leverage the thing, so which means they can jackpot a great deal of ATMs coming from different vendors, doing it pretty successfully. What is an interesting thing is those guys even don't bother to trying to invite the network using some programmatic way with phishing and whatever. They just the analysis of the malware proved that these guys need the physical keyboard in order to operate this, which means they just approach the devices, open the bay door, connect the keyboard, and do some stuff, and nobody cares. Don't know. These guys, as far as I understand, they were. I don't quite remember where they were operating. What their origins, but operating, they were trying to hijack some Mexican banks. Another pretty recent case of ATM heists. Fortunately, it didn't succeed, but very, very close. The actor is known as the code name of UNC 2891, or Light Basin, or as our red node friends calling it Liminal Panda. These guys, they proved to be not only good with NICS systems in Solaris. What the hell? One might need Solaris hacking. I don't know. Trying to get into the military, maybe espionage. Never mind. These guys, obviously they are up to some money things, and they prove to be not only good programmers but also they're real space ninjas. Because I love this example, because we used to have a particular guy in grade when I was there named David Jacoby. He was doing this kind of stuff all the day. So entering the companies and then trying to do stuff to them. So these guys managed to connect a Raspberry Pi single board computers to sell modem somewhere to the bank's internal network, to the LAN port. So they use a stage approach that gradually successfully compromised the network monitoring server, gaining extra visibility, and then the email server gaining a whole lot of stuff. So including the ancillary internet channel besides the Raspberry Pi itself. But where are the ATMs, you may ask? Well, okay, if not for the fact that the guys were caught because they tried to send some kind of ping through the pipe from the occupied monitoring server, and because of this, communication, some kind of keep alive to the CNC, whatever. It was detected by threat hunters because of some reason. They were doing an assessment on this bank system, and they discovered that something strange is happening. But these guys were one step from compromising the so-called hardware security model system. What exactly is that thing? So this thing is responsible for all transaction security across all the ATMs. I mean, this is some kind of a centralized encryption management system, hardware based. So they were able to hijack into the system. There is a server connected to some, I don't know, device. So if they were successful, they would become just transaction masters. They'll make green any fraudulent transaction. They were going to initiate at the ATM level, which were they going next. So this story is a good reminder that no type of endpoint protection doesn't exist as a spherical horse in vacuum. So the systematic, staged approach covering all the layers of your IT infrastructure is a must, especially if you have such sensitive devices inside the network. All right, so let us try to peek around the bend. So theorizing what the next is going to bring. To be honest, I borrowed some of the things here from my old pals Fabio Assolini's presentation, in the head of Great Latam. Extrapolated a few bits myself based on my own observations. So, first of all, ransom ops don't seem to go away, especially when combined encryption with data theft and blackmailing. Direct increase in unique users is micro, but I'll already have told you. So this numbers, I'm not telling the thing, but don't let it delude you. These attacks are very deliberate and focused, so it is about quality, not quantity. So they're selecting their targets very carefully, so making sure they are truly lucrative, tasty. So NFC, near field communication, attracting considerable attention nowadays. So the old techniques when you're using the phone's NFC to read cards, you probably heard the word NFC gate. Discovered recently that the guys were able to carry malicious applications based on the thing for NFC reading to the people's phones, convincing them to scan their banking cards. And therefore, in the end, the malware was transmitting the data, the token, to the other system somewhere else, where it could be used with, for example, an ATM or against a cashier or whatever. How it connects to the ATM? The more modern machines actually are able to communicate with banking cards through the NFC pads. So it's pretty okay. We're going to have the same scenario with just ATMs, where invade the ATM, infect it with malware, scan the user's cards. You don't even need to convince them. They will put the card into the pad, and then you do exactly the same, pass over the token and conduct a fraudulent transaction. Not very pleasant thing. So we must be aware of this stuff. So ATMs, die or evolve? After the COVID, it did a huge blow to the use of cash. And now, as we can see, this perspective is going to develop even further. So according to particular statistics, if you need the URL, I have it. The monitoring shows that there's some decline in the number of ATMs, but do they die out? Not exactly, because in fact, they've been evolving into the different breeds, such as instead of being cash dispensers in many cases, they evolve into some kind of multifunctional automated office with many extra functions. And I know for sure that quite a few banks are trying to capitalize on that and replacing their actual branch offices with living people with just devices. This also facilitates the evolution of malware from jackpotting, as I already have told you, to the more general banker-style breeds that are trying to hijack their transactions themselves. This is the same principle the regular banker malware is using. So AI, most of the time we try to tell that well, in most cases, this is a hype, but well, things never stay the same. And the LLM-based tools are developed in a at a rapid pace. So recently, a friend of mine here in Kaspersky presented in a conference about the method of automated, so-called, generally this is kind of automated pen testing method with all the sequence. They were connecting to the using LLM, different types of LLMs in order to probe the systems. And we'll collect a number of metrics, what already found vulnerabilities, and what MITRE approaches, MITRE techniques could be used against them. But this was a very deliberate, very systematized, well documented approach, very safe. But in case of cyber attackers, they're not restrained by any of these. So just remember that if they have an internet connection, they can develop a thing. They already do actually that tries to probe the system for different types of vulnerabilities. And even probably if they're successful in developing, they automatically applying some ready-to-use techniques. And we all know that a well-administered system, not really a spherical horse in vacuum, but in many cases it's easier to find than one may think. So it's to be beared in mind. And supply chain attacks. Always a thing to bear in mind, especially because there's the constant communications with third parties, because these things are complex. We need great deal of the service on these machines being made by very particular service companies. Therefore, introducing a huge risk of messing with the supply chain with third parties. So the companies must be vigilant against these infected on arrival cases. All right, so let us, before we get to the product itself, let me just briefly state what is a good thing to do in respect to different types of embedded devices. Having it upgraded to the most recent hardware and software is a good thing to do. Not any company can do this, but it's always recommended. Using multi-layered security, switching on as many layers as only possible, because in many cases this is not very flexible approach. You will either enable all the primary protection techniques, or you cannot protect your system. Using a trusted, reputable service provider, supply chain is a risk. Therefore, the company must pay attention to the security state of what they are relying on. So in case they in many cases, this is a relationship that has been established for years, and therefore they do good to both themselves and their partners in business if they will establish some mutual frameworks about assessments, about updates, and making sure that anything between themselves is going in a secure way. Approaches to protection. As you probably know, in many cases, especially for all the ATMs, allow listing has become a de facto standard for protecting these machines. It's good. Okay, it can substitute real threat protection in some cases, but as things evolve, it's good, but it's not enough, especially gradually these older machines fading away, which means the power will be becoming more and more enough for the more advanced protection. So, and conducting regular assessments is highly recommended. It's one case I just mentioned has proven that in case these guys were not checked and more educated, security expert were not moving in the network, they probably would be successful in their capturing over the ATM system. So, Kaspersky Embedded System Security, it is a dedicated solution supporting both Windows and Linux system, and it is built with all the mentioned peculiarities and pains relevant to both the particular types of devices and the customers using them. So, multi-layered security solution. It is not only multi-layered, but also with some layers switchable on and off to suit that scenario and the power level of the device. So threat protection itself is manifold, so file-based or even bundleless malware for that matters. Network attacks, exploits, all within this power. Security controls allow to apply external means of system hardening to the device. Naturally, they are here. So application control, device control, updating control, they're there. Dedicated ransomware protection, naturally. Firewalling, network threat protection. Remember, the network is one primary attack vector for many embedded devices besides the direct infection. Integrity controls, indispensable for any highly regulated environments. These are specially recommended by number of regulations. And here they also are a vaccine against offline manipulations, because in case of direct messing, so these guys can switch off the machine or take over the hard drive or what they have there and try to implant some kind of malware outside of any security precautions they have there. And by the way, encryption is not always the case, especially with a remote system. It's having trouble with rebooting the system. You cannot just go and enter stuff into the pre-boot environment. This can be the problem. So encryption can be not a solution to that as well. Optimization for low power system, Windows especially, with support of very, very old OS, down to Windows XP Service Pack 2. Speaking of which, of older and weaker machine, let me remind what the opt-in, opt-out approach is. For the most weak devices, you can run very lean, relying only on system hardening. It's about very, very old devices, yes. In some regions, still are there. They still must protect them. So more powerful devices can be secured more thoroughly, but in any case, when the scenario and power level allow, go full throttle. Enable all gold tech we have aboard. Threat protection, network protection, everything. So there are more newer devices nowadays. They allow that. So, but still, what is important to mention, you still will be able to operate the full zoo of having both the old and newer device operated from the same Kaspersky Security Center. This is important. Now that, I would rather say no other competitors can do this, because most of them just dropped out the support for all the systems. Well, again, it's time to go for the hottest stuff, okay? So, we had the last release, was signed, a few days ago. So what it brings us? Well, until recently, first and most important thing we have on board now is the full-scale behavior analysis, meaning we can now watch what exactly application tries to do as it starts and runs, not in emulation mode, in real time. So the technology is considered arguably the most powerful, by the way, for detection of unknown and sophisticated malware. And now we have it here on embedded systems as well. Previously, in previous version, there was only an emulative sandboxing kind of. Besides just malware detection, this technology serves as a basis for a number of other important technologies, such as automatic exploit prevention, different from the injective exploit prevention we used to have. It requires configuration. We'll show you a little bit later whether the difference. It is non-invasive, which is also important because of the requirement for continuity. So there is zero chance of incompatibility. So it doesn't inject any code into the running process. It just works. Also, more advanced encryption technology. So it remains extremely actual nowadays. Recently, I was looking through new cases happening to the relevant industries and the infrastructures involved in ATMs. And every second was about some ransomware operation, unfortunately. Also, remediation engine benefits from this system. I mean, the behavioral analysis useful for both the effects of encryption and for reverting back other adverse effects from malware presence. What else? USB attacks. So we have device control, as you probably remember. It allow listed peripherals, but with all these insider attacks, it's easy to imagine that some allow listed USB drive was taken by some malicious insider or is stolen from them, and then modified with some tools. They enabling it to simulate the keyboard and mice to make some input, but just insert it into the device. So this is what they call so-called bad USB attacks are. So now we have a bad USB prevention. So we detect such cases and just don't let them go. Another useful thing here, so we used to have only firewall management. So for Windows in particular, we now have our own firewall, which is an application level firewall. We're not only trying to restrict connectivity, but on the level of protocols and ports, but we can rule what particular application can do on the network, which losses we can considerably lower the risk of successful attack course because it supports the trust level system. So making it easier to configure, we can allow list whatever we need to, and all the system components are naturally allow listed by default, but the less trust, the less abilities it has on the network. And not unlike the HIPs, but we don't have HIPs here to have him. So, all right, that were a lot of words, but now let us share about some real stuff. So I'm passing the word to our mother of dragons, Evgenia Kirikova. Embedded system security, just a single dragon, but because she runs a full bunch of them, we now, thanks to that, we now have the richness of new features. So always good to remind about the mainstream features as well. So Zhenya, I'm passing the word to you.
Thank you, Oleg. Oleg, I have very good news. My demo stand is live, and I'll demo it right now. So.
All right. So I'm stopping sharing the screen, so you can take over.
Okay. Can you hear my screen?
Yeah, perfectly.
Okay. So I'll turn my video off. Okay. Let's start. Hi, colleagues. Very glad to meet you here in our evening session, and we'd like to share a small demo of our new Kaspersky Embedded System Security 4.0 version. First of all, I'd like to say that, as Oleg already mentioned, technical release and commercial release, even commercial release, have already took place. Commercial release was on 18th of November, so all product artifacts such as application build, application plugins, and application documentation, our administration guide are already on our Kaspersky public sites, so you can use them. Okay, and let us begin our small demo, and let's start with new policy overview. First of all, I'd like to show you the first feature that you'll see as soon as you open our new policy. It's a security level indicator. Here it is in the top of the policy in the upper left corner. You can see that now our security level indicator is red, and it states that we have low protection level in our policy. It means that some of our settings in our policy are not complied with Kaspersky recommendations. So what can we do with it? We can click link learn more and to see what's wrong with our policy. So here we once again can see that some of our settings are not compliant with Kaspersky recommendations. And then we can see a list of uncompliant settings. So we can review this list one by one, or we can just click this link, and our plugin will fix all wrong settings, and then we can see that our security level indicator turned green. So now our policy is fully compliant with Kaspersky recommendations. Okay, let's go further and see what new features were added in embedded system security. We'll start with the real-time computer protection setting. section. First of all, I'd like to show you two new components that Oleg has already said in his slides. It's behavior detection component and remediation engine. And we'll start with behavior detection component. Behavior detection is a very important component for overall computer security. Because this component monitors third-party applications' activities and analyzes their behavior and can block any activity if he finds it unwanted or so on. And another important part of behavior detection functionality is anti-crypto functionality. And now, as Oleg has already said, we have both protection of shared folders against external encryption and the protection for local folders. Okay, let's go further, and we'll go to the next new component, to remediation engine. And now I'd like to show you one more time how our new security indicator works. Now you can see that remediation engine is off, and security indicator of our policy says us that this component plays a significant role in computer security, so the indicator is red. We can fix it with enabling the remediation engine. So now our settings are fully compliant with Kaspersky recommendations. Okay, that's all for remediation engine, and we'll go further. Let's see what we have in exploit prevention. As Oleg already mentioned, our brand new exploit prevention component can now automatically identify protected processes. And let's have a look at it. But first we'll go to a previous version policy. Here I have some policy of previous version. We'll go to exploit prevention. And now you can see that here is a list that you can manually edit one by one. And it was fully in manual manner. Okay, let's go to our new policy. We'll find exploit prevention in 4.0 policy. Again, we have a security indicator that tells us that we must enable exploit prevention to protect our computer. And then you can see that there is a new option in exploit prevention, automatically detect protected processes. And still you have a list of processes, and you can still manage it manually. Okay, let's go further. I think that's all for our new components in real-time protection, and we'll go to the next new component that was introduced in Kaspersky Embedded System Security, and it's bad USB attack prevention. Okay, here it is. Our new component, bad USB attack prevention, prevents a computer from connecting USB devices that pretend to be a keyboard or any other human interface device, such as mice or barcode scanners or something like that. And when a user inserts a USB device that pretend to be a keyboard, and operating system identifies it to be a human interface device, a keyboard or any other device of such type, our component asks the user to type on this keyboard to authorize it. Okay, and here we can see two options, what to do when a USB device is connected to a computer. You can allow the use of on-screen keyboard, or you can allow a use of on-screen barcode to authorize a connected device. And here we have two options, what to do if user doesn't succeed to authorize connected USB device. Okay, now that's all with USB attack prevention, and let's go further. Let's briefly have a look what else was improved, and we'll go to trusted zone. There have been also small changes since the previous version. First, you can see two extra options that were added in our last version. The first one to merge exclusions in hierarchy, and the second one to use local exclusions together with exclusions from the policy. And the second improvement is an option, is an ability to use trusted system certificate stores. Okay, let's go further. And now we'll go to see what's new in our network activity control components. We'll start with firewall. As Oleg mentioned, in our previous versions, we have a firewall management component that allows us to put rules into Windows system firewall. And now we can use our own proprietary firewall to configure all necessary rules for network access. As in previous versions, there is still an option to observe the state of a system firewall, and it is for compatibility with settings imported from previous embedded system security versions. But if you want to change something in filtering rules, or if you want to create filtering rules from scratch, then when a proprietary firewall will be used, and here you can configure all necessary rules for inbound or outbound connections. Just for example, okay, sorry, they are empty, but there used to be some rules. And one of the benefits of using our own proprietary firewall is that now we can filter outgoing traffic even on Windows XP. As you may know, in Windows on Windows XP, that's not supported in Windows Firewall, and so there wasn't such an option in our previous versions of embedded system security. Okay, now let's go further. And we'll move to the next network activity control component. It's network threat protection. First of all, I'd like to notice that in previous versions, this component was located in another section of the policy. It was in real-time computer protection, but now it is in network activity control. And what's new? We have a new option in network threat protection. Here it is, and this option allows our application to monitor traffic to detect port scanning and high-intensity network requests. Okay, that's all for network threat protection, and we'll go to device control. Device control also got some changes and improvements. Sorry. In a new version, and we'll have a quick look at them. First of all, Wi-Fi network controls was added to achieve a feature parity with Kaspersky endpoint security. Also, we have another improvement here, ability to manage access to devices via connection buses. Here it is. And also, there was made an overall interface improvements, and interface was slightly reworked since there is a new type of restrictions via connection buses. So I think yes, it can be shown here. We can see new options depend on connection bus. Okay, now that's all. Sorry, I went something wrong. That's all for device control, and we'll go to the next component. It's system integrity monitor. System integrity monitor is a combination of two components that were in our previous versions, file integrity monitor and registry access monitor. So you can see these settings refers to file integrity monitor, and this set of settings refer to registry access monitor. And this improvement merged two components into one let us more efficiently track changes in the file system and the Windows registry. And so it will help to increase the protection against unauthorized modification of data. But it's not the only improvement that was made here. Also, System Integrity Monitor can now monitor connections and disconnections of external devices. That also can be useful to protect the computer from unauthorized data exchange. Okay, I think that's all here. And the last one thing I'd like to share with you, it's a managed detection and response component. As we already said in our previous presentations and calls, in the beginning of the next year, our colleagues from MDR plan to announce embedded system security support within managed detection and response service. So these plans are in the future, but we already have settings in embedded system security policy. So when the service is available, our customers can use and manage it from this place. Okay, now I think it's all from my side. Thank you, colleagues, for your attention. And Oleg, pass the word to you back.
Thank you. So let me share back the slide deck. All right. Score the things. Okay. Good. So thank you again once again for all the good demonstration, lots of new interesting features and making our embedded systems protection really powerful. But what is going to be next? So, okay, I'm trying to click, but nothing happens. You just wonder. Okay, it worked. Can you see my screen now?
Yes.
Fantastic, thank you. So, as you can see, we have plans for the closest quarter. So in order to have a better feature parity, so we introducing the bad USB prevention for Linux systems as well. One great surprise for us all from the MDR team. So as Evgenia just have shown, the option of enabling the MDR. So the official support from the service itself start from the quarter one around February in the end of January. Can you please clarify, Evgenia, when they promised to show everyone?
As far as I remember, it was February or March.
All right. So anyway, well, Q1 we'll have it definitely on the level of the service itself. I strongly believe that in case this is a deal enabler, we can discuss it even now with our customers. What is also important for the Linux in particular is everything progresses and the RAM architecture is taking a great strides to take over the embedded industry. The devices based on this architecture are simpler, cheaper, more cost-effective. and they're going to take over the world very soon, I believe, in many areas. So we understood that, and we also had a few requirements through inquiries from the customers and partners alike. So here we are. We are offering ARM processor support. So we're going to have a KSS for Linux next quarter with ARM support. So I really do hope this can be an enabler. Some banks about to seize an opportunity, for example, as far as I understand, they weren't able to purchase more expensive devices from the leading vendors, but now there are lots of Chinese ARM-based things going our way. Therefore, this is our chance to secure this part of the market, especially given, well, the competitors do not sleep. We have a question. Do it will support integrate with EDR expert? No. Again, can you comment? So far, it doesn't support EDR. So
Yes.
take the difference.
Yes, actually, we do not support at the moment EDR in embedded system security, and actually, we have no plans to support it. We discussed with colleagues from EDR, and we came to conclusion that managed detection and response at this time can be the best solution for embedded systems security. But if you have opportunities to support EDR in cases for Windows, so please write me, and we can return to this question again.
Well, still, one must understand that the balance of all compatibility and doing stuff within such a system is more delicate compared to regular computers. So, not always that safe to conduct the remediative action with embedded systems as it is with general computers. So having expert advice what to look at and the best responsibility could be the best course of action for now for us. Okay, so just a couple more words about Linux, because we are very keen on making it as well protected as we have Windows devices. So we are striving for feature parity. So naturally, we didn't have any proprietary application level firewall for Linux. We just don't have it even in the general protection. So here is cross. A log analysis, logging in Linux is much more complicated and chaotic compared to Windows. So far we don't have any analysis for Linux. Self-protection, same thing here. So far I really do hope we'll be able to introduce some advancements in that matter. Zhenya, you were telling something about introducing another kernel model so we would have a presence at the kernel level.
Yes, as you may know, we have introduced a universal Linux kernel module in our another Linux application, Kaspersky Endpoint Security for Linux. And we have some ideas, and we plan to run a technical proof of concept in next years to see if we can improve our self-protection on Linux with this kernel module. But as you may know, it's very complicated on Linux with defense from an administrator. As you may know, root can kill anyone and everything. So it's still ideas in a stage of
discussion.
Yes, in a stage of discussion, in a stage of concerning of a proof of concept, if we can find a way to do something in terms of self-protection.
Okay, so thank you so much. It will be great to have this. Having a UKLM gives us lots of advantages here. Suddenly, but speaking of advantages, suddenly the Linux users are going to have one in respect to web threat protection, because we were really keen on maintaining a low resource footprint for the Windows systems. And despite it may sound ridiculous for some, but there are a great deal more of obsolete, very low power Windows machines compared to Linux ones. I mean, the embedded computers. Most of the Linux ones are considerably newer, fresher, more powerful. So we didn't, the same need to make it as little footprint for the Linux. So we kept the web threat protection, and for Windows, in order to support those, crappy machines, we had to cut it out. All right. Let us speak a couple of words about the selling things. So naturally, this is a niche product. Therefore, some vendors don't even care about protection of older machines. The same goes for the not really big companies or smaller banks, for example. They don't even try to put some proper protection, even in case they clearly need it. So they configure some kind of basic system hardening. That's it. Not always even bother to go with the requirements of the regulators. So we have it fully set for any kind of customer, actually, starting from the those poorer, less budgety, cost-effective companies, and up to the level of big enterprises, given their full park already upgraded. So speaking of more about the value proposition, so our offering actually present the lowest in class system requirements. I will list it through a great deal of competitors offering, even those using only system hardening, and even in that our offering was having the lowest system requirements. Maybe I missed something, but so far, it was so. We have a really good combination of additional security measures, such as system hardening is combined with integrity monitoring, good self-protection. And support is for obsolete version of such as Windows XP is absolutely unique for B2B. Take notice that because as I don't know any other vendor who still supports such old stuff in their B2B solutions. We also position this product for protection of general purpose machines, because there are quite a few outside of the embedded world. Most of the time they are used for some unique purposes, running some unique parts of software. For example, there are no analogs, they never were upgraded itself. Therefore, they had to keep those older system alive in order to operate some unique scientific machinery, for example. But still they need protection. This is the opportunity to have a full-scale modern protection on these machines, despite everybody else doesn't support this. What else? We still see that support for the weak communication channel is also important, because many other vendors, especially trying to maintain a low resource footprint, is trying to rely heavily on the cloud. We will not putting all the eggs into the same basket. This is important also. So therefore, we're trying to maintain good level of security regardless of the channel, and even a 56K modem, the old one that is whistling into the line, will be enough for us to operate. And Windows and Linux supporting the same product is a good thing to have. Not all the not that many competitors actually have dedicated solutions for embedded system security. Most of the time they offer a general endpoint security for such machines. Okay, say a sales scenario, I'll pass over. You can read it in a sales training or the product presentation. But two things we need to always bear in mind when speaking to the customers who are, as I already told it, budgety. So some of them naturally try to install the regular endpoint security on embedded devices. Well, because it is kind of cheaper, which brings us to what are the difference. So first of all, still it is specialized equipment, special periphery. It's all built around the very purpose of being well continuously functioning without any maintenance. Well, some devices are not being approached by technicians for months or even years until some mechanical failure happens. So therefore, this solution was tested, unlike the next line with this kind of devices, operates alongside the most available middleware. So we know it works. And also, the last but not the least, we have those additional security layers such as integrity controls that are not readily found in the cheaper endpoint protection. They say in other scenarios, these ones are generally associated with service security. So this is extra with our competitors, or in case of our own solution, you can in the next slide you can find support for this in the upper tier, such as XDR Expert, where they actually which have the hybrid cloud security incorporated inside, or you can they can also go and buy hybrid cloud security in order to satisfy the recommendations of the regulators. So it's not a good thing actually. So use PSS on those devices, not next. And another juxtaposition is against KICS. This is an opposite situation because KICS is even more expensive compared to KSS. And people think that, well, this is just different kind of embedded systems. What can be wrong? And this is very, very incorrect understanding, because besides even considerably more thorough testing with the industrial setups where the continuity is alpha and omega, I know of several support cases that were brought into existence by those guys who are trying to employ regular, well, KISB at the time, in their industrial infrastructures. And one more thing to mention, in case those guys are trying to do some really serious stuff and not just, well, checkbox security, they probably will need to work with the industrial protocols. Well, so implement a multi-layer system on, will operate in a different levels. So industrial infrastructure. So they need to look not only just protect the industrial endpoint like devices, but also watch for telemetry. And telemetry involves not the regular types, not only the regular types, but also specialized industrial protocols. And naturally, we have support for industrial protocols in KICS, and KSS doesn't support this. So this is absolutely must. So KSS was not designed for industrial environments. So, and in case there is any inconsistency, our support team will have to wave their hands to say, sorry guys, well, you should be more thoughtful before doing this. And one appendix, it was good to, well, consider some co-sales or vice versa, using some different offering as a door opener for, well, for embedded system security in our case. So security assessments are always a good thing as a door opener, especially for those happy-go-lucky guys who think, well, who will care about intruding into my system? When money is involved in smaller banks fall victims to the cyber criminals, and the discoveries made during the course of an assessment can be quite, well, refreshing, I would rather say. Well, including the understanding what security countermeasures can actually work against modern threat landscape. Cybersecurity awareness is always a good company for embedded security, because in many cases social engineering is being used, or just general understanding how it works in such scenarios. So the case with the Raspberry Pi, for example, makes one think, how should we treat the I don't know, visitors? Even watch for how they operate the network security. So do we watch for I don't know, stray sources of traffic you suddenly discover on a network? You should take this into consideration as well. And general social engineering is always a tool for a primary intrusion. The instant response is the same as security assessment. In case something happens, there are discoveries, and a good thing to recommend a solution that could help in the case. So, any case of a bank or retail or a medical institution doing instant response, make sure the guys who are going to conduct the service will able to think of car sales. And professional services are also there because these things can be complex, especially in order to ensure proper continuity of everything would work perfectly and provide a good level of protection. We can do it for them. We can implement. We can optimize the configuration, and in order to make them sleep well, so we can conduct a compliance assessment, for example. So making sure that everything that a modern version of PCI DSS, for example, requires from companies, what suit the requirements to what they have. So, hope you enjoy it. We were trying to make it as fast and furious and lively and educative as we only can. So, let me now check the chat window. We're out of the time, but still, I really do hope some questions were already answered by Evgenia. Okay, thanks for demonstration. Question, yes, agree, will be the same. Okay, local GUI, Eugenia, will you answer? Something about the roadmap. What was that?
I have a question for you if you let me.
Oh, yes, please do.
Thank you so much and have a great day, colleagues. Is it correct to say that our exploit prevention model in CAS it's an approach of a virtual patching solution? I'm asking this because currently we have some financial institution customers and some banks asking for specific virtual patching solutions. We are aware we don't provide such kind of solutions, but we'd like to know your thoughts, your insights about it. What do you think?
I would rather say it would be safe enough to say yes. Because as far as I know, the virtual patching technology is essentially it's an injective-based technology, not unlike the previous version of exploit prevention we used to have on the previous version of KSS. One that better to be kept omitted. There are some techniques used by Trend Micro that are actually operating on the level of traffic. Therefore, trying to cover some vulnerabilities, like do something on the level of packets, as far as I understand. But still, our network threat protection also doesn't stand idle. So I believe, if not for this technology and for the other one, the AAP plus the network threat protection, we would have the equivalent of virtual patching.
Got it. Thank you so much, Oleg.
Oleg,
Yeah, Marcos. Great.
how are you?
Yeah, fine, thank you.
Thank you for your presentation. I have a question for service
Okay.
related with security assessment, payment system security assessment. That is available
Yeah,
for Americans nowadays, or it's not available?
it's a good question. I'm inclined to think that we can do it for Latin America. Hardly so for Northern America, but I probably will need to. I can clarify with the guys. It doesn't. It's a no-brainer. I'll just go to them and
Okay,
ask if we can deliver it in your area.
okay.
Any country in particular, or in Central to Southern America?
Yeah, it's in South Sola.
Oh, Sola. Okay. Cool. I'll make an inquiry.
Yes. Yeah, I think it's very important for the kind of customer here, retail mainly
Okay.
is a
Can you
huge
please,
company.
just in case, so it would serve in an extra business justification, can you send me an email with the opportunity details? Okay.
Perfect, perfect. Thank you,
So
Oleg.
there is sometimes there are cases when the guys will say, "Oh, we usually don't do this, but it's a good case, a good prospect, so probably we'll just go and do it." It happens. Well, but I strongly incline toward thinking that they will do it anyway. Okay. Any other questions? All right. No, nothing else. But anyway, if you think of something, you need to inquire or have some questions or from a customer during your next meetings, and we'll just bring it to us, and we'll do our best to support you in the sales process. Well, thank you guys. It was a great time with you. So really do hope it was enjoyable. So looking forward to the next webinar. I think we're going to have them. Well, I don't know. Most likely in quarter four, 2026. But let us see how it goes because we have certain activities around Linux operating system. Well, in general, we used to have a panel with Alexander Liskin and with Gulnaz Rahimova, who is the product manager of KSC now, around Linux. So this was for general Russian audience, but probably it will be of interest to the global audience as well. By the way, you can let me know if you have if you have in mind that we can do something in your area, well, for your particular audience about the Linux in general, looking into different cases, including the embedded. Well, I'm your guy, so I can help with that. All right then. So it's the evening, so I need to switch for another meeting. Thank you guys. Thank you for joining us. Well, looking forward to meeting you again online or in person.
Thank you,
See
colleagues.
you and take care. Thank you, Zhenya.
Thank you, Oleg.
Have a good, great
Have a great day, colleagues.
Thank you. Bye.